Hello friends, welcome to Science Tutor. In this video we shall be looking at benzene. Benzene is an aromatic compound, is an aromatic hydrocarbon that simply consists of benzene and compounds that are related to benzene. So we have the key man, benzene, then compounds related to benzene such as xylene, we have toluene, we have phenol, etc. and so many more. So compounds that are benzene and related to benzene are basically aromatic compounds. They have similar characteristics, similar resemblance to some extent. So benzene basically is having the formula, the molecular formula C6H6. In terms of the structure, 6 carbon attached to 6 hydrogen. In terms of the structure, according to Kekulé, it's drawn this way, 6 carbon bonded by hydrogen. So we have benzene to be drawn in this manner, in which we have each of these connected. Now this represents 1, 2, 3, 4, 5, 6 carbon atoms attached to a hydrogen. Each of these represents hydrogen. But for Kekulé, he specified series of bonds, double bond here, single bonds, double bond, single bond, and then double bond. In another case, it was also considered to exist in this manner, in which it seemed as if the bonds are rotating, but from bond length studies, it isn't rotating, so these bonds are simply shifting. And that led to the concept of what we call resonance. When two structures are intermediate, you can see it seems as if we have some sort of rotation in the bond, shifting, double bond, single, double bond, single, double bond, single, and then we have the word we call resonance. Resonance simply talks about structures that are intermediate in nature. So, from bond length studies, it was also seen that the structure of benzene can, based on this resonance, can be written in this form: a hexagonal structure carrying a circle, a cyclic figure in it. So, this is considered the real structure of benzene, C6H6, embedded in a circle having a hexagon, six-sided shape, benzene ring, from bond length studies. So this is benzene. From benzene, we can also generate other aromatic compounds. For example, the likes of toluene can be drawn from benzene. Xylene can also be drawn. Phenol, for example, consider phenol. Phenol is obtained, remember this is C6H6. To draw phenol, I simply remove one hydrogen from benzene. So the structure of phenol goes like this. Of phenol, I still have a cycle bonded by my hexagon. In this case, I'm going to be having a CH3 group. Or for phenol, let's begin with phenol. We have an OH group. Phenol, from the word all, it has an alcoholic group here and a hydroxyl group that gives it the OH. So phenol, OH. So this is the structure of phenol. It has the same structure as benzene, but replacing one of the hydrogen atom by the OH group. So structurally, molecular formula, I can write it as C6. Instead of H6, I'll be using H, a drop in one hydrogen, H5, and then I have OH. This is the structure for phenol. So that of toluene, toluene is also having the same shape as benzene, but there is also a drop in the hydrogen atom. So we have benzene. For toluene, we have it connected by a CH3. So one of the hydrogen atom is being replaced by a CH3 group. So it simply means we have the compound to be C6H5CH3. That is for toluene. So this is toluene. How about xylene? For xylene, we still have the same structure of benzene. That is why we say they are related to benzene compounds. So we still have the same structure, but in this case, the hydrogen atom is replaced by a double CH3 group. This is one CH3, another one here, CH3, which at the end of the day makes the compound to be C6. One hydrogen reduced here, another hydrogen reduced here, making hydrogen to be 4. So CH4, CH3 twice. So the hydrogen atom drops by 2, making the methyl group to be double. So this is how to draw each of these. Benzene ring C6H6, a drop in one of the hydrogen and replacing by an OH gives us a phenol, and then a drop in one of the hydrogen atom replacing by a CH3 gives us toluene, and then a drop in two hydrogen atom replacing by a methyl group gives us the compound xylene. These are aromatic compounds. They are compounds of benzene and are similar to benzene as well. Likes of phenol, xylene, toluene. These are their structures. I'm sure we got value from this video. Please do well to like my videos, subscribe, and share for more persons to see. See you next time. Bye for now.